Hello learners, welcome again to my channel. I'm your teacher Alice, and today we are looking at our lesson 2 on the topic water and hydrogen. Remember last week we were looking at the preparation of hydrogen, so we saw how we can prepare hydrogen gas in the laboratory using zinc metal and dilute acids. Then we also saw the methods of collection of hydrogen gas and also the drying agents and what have you. So in lesson 2, we are going to look now at the chemical properties of hydrogen gas. And the first chemical property of hydrogen gas, we are going to look at the reduction property of hydrogen gas. So, is hydrogen a reducing agent? We are going to look at this using an experiment. This is the setup here that we are going to use. We have our combustion tube here containing copper 2 sulfate in a porcelain pot. Then we have anhydrous copper 2 sulfate on the other side of the combustion tube. Then remember we are heating our copper 2 oxide here. Then here we have supply of dry hydrogen gas. So then at the end here, we are also burning our excess hydrogen gas. So we are not releasing our hydrogen gas to the air. And we can see that there will be a reaction taking place here between copper 2 oxide and hydrogen gas. So we say when hydrogen gas is passed through the combustion tube, it reduces copper 2 oxide. So when copper 2 oxide is reduced, reduction, remember, not here, reduction, ama removal or the removal of oxygen is the removal of oxygen from a compound is what we are referring to as reduction. So when hydrogen removes oxygen from copper 2 oxide, it will form copper metal. So we are going to have copper metal. Then hydrogen gas itself is going to be oxidized. So we said oxidation is the addition of oxygen to a substance. So when hydrogen reduces copper 2 oxide to copper metal, itself is oxidized to water. So hydrogen reacts with copper 2 oxide to form two products, that is copper metal and water. Remember, water is an oxide of hydrogen. It is the same as hydrogen oxide. So when copper 2 oxide reacts with dry hydrogen gas, it forms two products, copper metal and water. The reason we heat copper 2 oxide is to make it reactive. Then we cannot release hydrogen gas to the atmosphere because when hydrogen combines with air and then when it is ignited, it is very explosive. So for safety purposes, we do not release excess hydrogen to the atmosphere. Then what is the purpose of this anhydrous copper 2 sulfate here? So anhydrous copper 2 sulfate is for the tests that whatever we are going to form, the liquid that will be formed here will be water. So anhydrous copper 2 sulfate is used for the test for water. So where will water form? Water will form at this end. This side, that the cooler side of the combustion tube, this is where we are going to have our water. So there will be formation of a colorless liquid at that point. That colorless liquid will be water. Well, that liquid is going to turn this anhydrous copper 2 sulfate from white to blue. That will indicate that the product or the colorless liquid that is formed there is water. Okay, move to the next slide. So the above experiment was to show the reducing property of hydrogen gas. we have said that air, first of all, air is driven out of the apparatus. So we first pass hydrogen. We first pass air before passing hydrogen. So before we pass our dry hydrogen gas, we first pass air. We drive air into the apparatus to ensure that now the hydrogen that we shall be driving in will be very pure. Then, because we don't want the hydrogen to mix with other gases that might be very explosive when we ignite at the end of the experiment. Then, on passing a stream of dry hydrogen gas overheated copper-2 oxide, we said the color of copper-2 oxide will turn from black to red-brown. So, to indicate that the reaction has taken place, the color of copper-2 oxide will turn from black to red-brown. So that would have confirmed that the hydrogen that we have passed through the copper-2 oxide has reduced it to copper metal. So the red-brown substance formed there is copper metal. Then a colorless liquid condenses and collects at the cooler part of the combustion tube. We have said that the colorless liquid is water. So hydrogen combines with oxygen from copper-2 oxide to form water. So hydrogen removes oxygen from copper-2 oxide. Therefore, it is referred to as a reducing agent. So that experiment confirms that hydrogen is a reducing agent. Copper-2 oxide loses oxygen to hydrogen. Therefore, it is known as an oxidizing agent. So copper-2 oxide oxidizes hydrogen to water or to hydrogen oxide. So it is an oxidizing agent. Hydrogen can also reduce oxides of lead and copper. So you can see the two reactions where hydrogen gas is reducing lead and iron oxides. Hydrogen does not remove oxygen from oxides of more reactive metals, so it cannot all those metals that are above hydrogen in the reactivity cell list, it cannot reduce the oxides. So the supply of hydrogen gas is continued while the apparatus cool. This is to avoid the reoxidation of copper metal by oxygen from the air. So when we are done with our experiment, so after we observe that copper-2 oxide has been reduced to copper metal, we continue with the supply of hydrogen gas, and this ensures that the copper metal now that was formed after reduction is not again reoxidized by the air to go back then to copper-2 oxide. Then excess hydrogen gas is burnt because its mixture with air is very explosive when it ignited. So it is not allowed to pass. It is not allowed to escape into the air for safety reasons. So that was the experiment to prove that hydrogen gas is a reducing agent. Property number 2, that is burning of hydrogen in air. So what happens when we burn hydrogen in air? So we have an experiment here. This is a setup to show what happens when hydrogen gas is burnt in air. So hydrogen gas, we are going to pass our hydrogen gas through anhydrous calcium chloride. This is in a U-tube. This is to dry our hydrogen gas. So anhydrous calcium chloride is a reducing agent. We saw that. So now our dry hydrogen gas will now be ignited here. After we pass it through anhydrous calcium chloride, we are going to ignite it here at the end of this delivery tube. So you can see that when it is ignited, then we have our ice cold water that is cooling whatever is being formed here. It is being cooled, it is cooling the gas, it condenses the gas to form a colorless liquid that is collected in this beaker. So when hydrogen burns in air, a colorless liquid which turns anhydrous copper 2 sulfate blue is formed. So, which is this liquid that is turning a white anhydrous copper 2 sulfate blue? This liquid is water. So, that means hydrogen gas, when is burned, it produces water. So, we say hydrogen combines with oxygen from the air to form water. Water is therefore an oxide of what? An oxide of hydrogen. This is the reaction that is taking place there. Hydrogen plus oxygen to give us hydrogen oxide. Anhydrous calcium chloride is used to dry the gas, we have said that, and then the ice cold water condenses the steam to form liquid water. So that is the explanation for burning hydrogen in air. So at the end here we have extended questions. So we can answer maybe the first question together. The setup below is used to investigate the properties of hydrogen. So this is what we have just learned. Dry hydrogen is passed through a compression tube containing copper 2 oxide, and then at the end here we have a flame. So we are told on the diagram, indicate what should be done for the reaction to occur. So what is missing here is the supply of heat. So there should be supply of heat here to make copper 2 oxide reactive. So copper 2 oxide is missing at that point. Roman 2, hydrogen gas is allowed to pass through the tube for some time before it is lit. Explain. So before lighting, we have to ensure that there is no air in this combustion tube. So that is why we are passing hydrogen gas before we light here, to ensure that now whatever we are going to light here will be pure hydrogen gas to avoid explosion. So that is why we first pass hydrogen gas, or we first pass air through the combustion tube to ensure that the hydrogen that will be passed there, or the hydrogen that we are going to light to ignite at the end there, will be pure hydrogen to avoid explosion. Write an equation for the reaction that occurs in the combustion tube. So this is where the reaction will be taking place. There will be a reaction between copper 2 oxide and hydrogen gas. So those are the two reactants. Then the products will be copper metal and water, to show that copper 2 oxide will be reduced to copper metal, and hydrogen gas will be oxidized to water. Roman 4, when the reaction is complete, hydrogen gas is passed through the apparatus until they cool. Explain. So the reason we continue with the supply of hydrogen gas is to ensure that the copper metal that is formed is not reoxidized to copper 2 oxide again. So it is to ensure that copper is not reoxidized to copper 2 oxide. Roman 5, what property of hydrogen is being investigated? This is the reducing property of hydrogen gas. So that is the property that is being investigated there. What observation confirms the property stated in Roman 5 above? That is the color. The color of copper 2 oxide will turn from black to red brown. The reason is because copper 2 oxide will be reduced to copper metal, that is red brown. So that is the confirmatory test that that hydrogen is a reducing agent. Then why is zinc oxide not used to investigate this property of hydrogen gas? So zinc is above hydrogen in the reactivity series, therefore hydrogen cannot reduce the oxide of zinc. So that is the answer to that one. So you can pause, so feel free to pause this video and make sure you can answer the second question here. It is in our notes, and even in the previous video we can get our answers for the second question. So that will be our lesson 2.